Okay, our one last thing to talk about for this section is talking about what a zero of a function is. A zero is an input, or the x, that makes the output 0. Meaning, what x do I put in that gives me out a y of 0? So when I'm asking to find the 0 of a function, I'm wondering, hey, what x's do I put in to get out a 0? Okay, and so we've actually been finding zeros of a function. We found them up here on this guy when we found that when I put in a 0, I get out a 0. And when we put in a 2, we got out a 0. So the zeros for this function up here, the zeros are 0 and 2. And maybe 0 and 2. Because they are the two numbers that when I put in, I get out a 0. Okay, and so one great way to find them, if you notice here in the graph, those zeros are really just the same as those x-intercepts. So to help find those zeros, we find those x-intercepts. Okay, yes, because this point tells you that x1 is an intercept of the graph of S. It also tells you that when I plug it in, I get out a 0. That makes it a 0 of the function. Okay, so if I'm looking for this next problem here, is it says solve. I want to know where 3x squared minus 18x plus 15 equals 0. So really here, I'm trying to find the zeros of basically the function f of x equals 3x to the second minus 18x plus 15. I'm trying to figure out what inputs in here. I'm looking for the input that gives me an output of 0. So we're going to go ahead and we're going to find that graphically. I'm going to show you two different ways. First, I'll show you with a graphing calculator. Okay, because we can find them with a graphing calculator. It's a little harder. It doesn't just jump to them as quickly as Desmos does. So I go to my y equals. Let's go ahead and delete what's in there. Clear what's in there. And my plots are on. I'm going to turn my plots off. Okay, and I'm going to graph that function. So 3x to the second minus 18x plus 15. Okay, and I'm going to go and I'm going to look at the graph. Okay, first of all, my window's weird. If you notice, this goes like 20,000. So I'm going to hit my zoom button and I'm going to go to zoom 6 standard screen. There. That's a little bit better. I can't quite see the bottom, so I'm going to go to my window. I need to be able to see farther down. Right now, I'm only seeing down to like -10 right over here. So I'm going to go to my window, and for my x minimum, my y minimum, how far down I see, let's go ahead and let's make that -15 better. Okay, so there it looks like that's possibly my vertex. We trace. What is that at 3? My vertex looks like it's at 3, -12-ish, but I'm looking for the zeros. Okay, so if I trace, I'm looking for, oh, and it jumps to it. Yours will not do that. You're going to have to find them or type them in. So 1 gives me a 0, so there's a 0 of 1, and then it looks like the other one's over there, maybe at 5. 5 is also a 0. So my zeros are at 1 and 5, and I can find them using my graphing calculator. It's important to know how to do those because you won't always have access to Desmos like on a state test. Desmos, I can do the exact same thing. I type them in. So I type in 3x to the second, y equals, let me do is y equals 3x to the second, minus 18x plus 15. Oh, sorry, my caps lock's on. I can just, those points just pop up there and I can just tap them. 1 and 5. So those are the two numbers that when I put in to this function, x would be 1 or x would be 5. Either one will work. And if I plug them in there, 3 times 1 to the second minus 18 times 1 plus 15, it might look like this isn't going to work, but it will. Because if I do order of operations, 1 to the second is 1 times 3 is 3. 18 times 1 is 18 plus 15. 3 minus 18 is negative 15 plus 15 is 0. So 1 worked. 5 also works. 3 times 5 to the second minus 18 times 5 plus 15. 5 to the second is 25. 3 times 25 is 75 minus, 18 times 5, 90. 75 minus 90 is negative 15 plus 15 is 0. That one worked as well. So both of those points will work, and we were just finding the zeros of that function. What inputs give me an output of 0? Okay, all right, we have one more application type problem. So we have professional cliff divers are using a platform that can be set to a range of heights. So use the function. This is a free fall function, meaning this gives me the distance given time. So first let's understand this function. Okay, this function, my input is time. Okay, oh, and I'm sorry, I don't have the units. Time, I believe, in seconds. I'd have to reference. This is a book. This is a problem from your book. I just don't think I put that in there. Is the time in seconds. Okay, and the d of t, the output, is the distance from the water. So for example, if I want to know after 1 second how far I am from the water, I'd plug in a 1, 16 times 1 squared. Okay, so 16 times 1 would give me 16. So that would give me 16 is that distance in feet. Distance from the water in feet. So I'd be 16 feet from the water. Okay, so forth and so on. Okay, well, the distance I have traveled, right? Okay, the distance I have traveled. Okay, but I'm starting out, so I guess not distance from the water, distance traveled, distance, output distance, let's get rid of this. Distance travel, distance traveled. Meaning after 1 second, I'd have gone 16 feet. After 0 seconds, I haven't gone anywhere. I'm going to give you 0. I've traveled 0 feet. Okay, we're starting. So basically, I need to figure out, I want my distance traveled to be 16 feet because I want to hit the water. So I want my distance traveled to be equal to 65 feet. So I basically want my 16 t to the second to be equal to 65 feet, meaning I hit the water. Because I will have to travel 65 feet to hit the water. Okay, so the first thing I'm going to do is I'm going to subtract this 65 to the other side, because I need to set it equal to 0 to be able to find the zeros. So now what I'm going to do is I'm going to graph this. I'm going to come in, I'm going to grab Desmos, and we're going to graph this. Y equals, so we have 16 x to the second minus 65. Okay, and we're going to look here. So we get approximately negative 2.061, positive 2.061. But again, remember, this is time. We're finding the time it takes me to hit the water. I can't go back in time. That negative time makes no sense. So there are 2 zeros for this function. There are 2. T is approximately negative 2 or positive 2 or 2.16? 2.016, so 2.02. I think 2 seconds is probably sufficient. Think about how many decimals we think we need if we're talking about time for seconds. And again, it says we're approximating. Okay, the negative 2 does not make sense, so it takes around 2 seconds for that diver to hit the water.